In simple terms, it says particles don't accelerate without unbalanced forces. Now, I highlight the word accelerate and unbalanced. I'm not saying particles don't move without unbalanced forces. First of all, what do we mean by unbalanced forces? This pen right now is under the influence of gravitational force and a bunch of other forces, but they're all canceling each other out. We call it as balanced forces. I push this pen from both sides. If the two forces are exactly equal to each other, balanced forces. Okay, so that's what balanced and unbalanced forces are. Now, if there's an unbalanced force, that means, for example, there's a force acting this way, and there's no one to counter that force, then we will say particles accelerate. It doesn't mean that particles will move like what most of us like to believe. For example, right now, on me, there are no unbalanced forces. Every force is balanced. There's a gravitational force downwards. It's a normal force. The chair is pushing me up with a normal force. So the total force acting on me is 0. Therefore, I'm not going to accelerate. It does not mean I'm not moving. Am I moving? Yes and no. It depends upon who's observing. Depending upon if there's an observer sitting right in front of me, and he would say I'm not moving. But with respect to someone on the moon right now, I am moving. So whether someone is moving or not is dependent on the frames of reference, depends on the point of view. However, if someone is accelerating or not does not depend on point of view. Okay? So as long as there are no total net force acting on my body, every observer will agree that I am not accelerating. You get that? I repeat, if there are no unbalanced forces acting on me, if the total force acting on me is 0, all observers are going to, well, all inertial observers will say, but anyways, all observers are going to say that my acceleration is 0. That's what we mean by Newton's first law. So as long as there is no force acting on a particle, that particle will not accelerate. Okay, this law is also called as the law of inertia. And inertia is the ability for a body to stay at rest or stay in motion. Now, while explaining, I did mention there's something called as inertial reference frames. Inertial reference frames and non-inertial reference frames. And that's important. What do we mean by an inertial reference frame? Well, let's take an example. I have a car that's moving towards the right at 10 meters per second. I have a bike, that's moving towards the left 5 meters per second. And there's a bird over here, maybe, whatever the bird is. It's going this way at 3 meters per second. None of these are accelerating, okay? And then I'm standing, this is me, I'm standing over here, just here, over here somewhere, just chilling out, looking at all the vehicles and stuff, okay? And let's say there is something else moving. There's a boat here, okay? I don't know where the boat comes from. But this boat is moving towards the right, and not just moving, it's accelerating. 2 meters per second square. Okay, we have the situation. So we have the car, it's called C. We have the bike, B. We have Mashi, that's M. And we have the boat, B. And we have the bird. Let's call that bird as some A. Okay, look at these people. If you asked any of these guys whether I am accelerating, these guys will say, nope, I am not accelerating. So the bird will say, I am moving this way, but I'm not accelerating. The car will, this car will say, I'm moving this way at 10 meters per second, but I'm still not accelerating. Bike will also agree that I am moving this way at 5 meters per second, and I'm not accelerating. And if you ask me, I will obviously say, no, I'm just standing there, I'm not accelerating, there's no one pushing or pulling me. You see, Newton's first law works for all these guys, no problem. But now let's look at things from this fellow's point of view. If this fellow believed that he was at rest, in relative motion, we always like to believe that all reference frames are at rest, okay? So if this fellow believed that he's at rest, then according to him, I am accelerating this way, right? Because he feels that he's at rest, the ground, the whole world accelerates this way. And therefore, according to him, I am accelerating, and therefore, there must be an unbalanced force. There must be a net force acting on me. That's what he says. But there is no net force acting on me. So you see, whatever he's observing and his conclusions are wrong. And that's the whole idea behind a non-inertial reference frame. Non-inertial reference frame basically says it's a reference frame that itself is accelerating. Okay? So you can only use Newton's first law provided you are in an inertial reference frame. So a simple meaning of inertial reference frame is non-acceleration. Any reference frame which is not accelerating is inertial. So this guy is inertial, this guy is inertial, this guy is inertial. Even I am inertial, not because I'm at rest, because I'm not accelerating. But this fellow is non-inertial. And a non-inertial reference frame basically means accelerated reference frames. So in accelerated reference frames, the Newton's first law does not work. So from his point of view, even if there are no forces acting on me, and he can confirm that, he sees no forces acting on me because force is not a relative term. There are only 4 forces of nature, and we would know if there are forces acting on me. So he confirms that there is no net force acting on me, yet he sees that I'm getting an acceleration this way, which immediately says that this is non-inertial, so do not do any physics from this point of view. We will see later, even if non-inertial reference frames, how we can do the physics by inventing some pseudo forces. We're going to talk about that later. But that's first law and inertial and non-inertial reference frames.